All right, good evening, everybody. We're going to get started here. I'm not used to being so loud, but welcome everybody to RevitDC for our February meeting tonight, everyone here and everyone who's online, so thank you all. We've got a good amount of people here today, and that's great. And for those of you who are coming to see Jeff Gravitt tonight, I'm sorry he's not going to be here. That'll be the next one. You can see Jeff do all the introductions. My name is Galen Hofflinger. I've been affiliated with RevitDC for quite a few years now. How many people are here for the first time? Very good. Thank you. Welcome. Let's just move on to the next ones in here. We have RevitDC is part of now 4 Revit user groups in the area, sponsored by CAD Microsystems. One in Baltimore, one in Richmond, and one down in Raleigh-Durham area. So Revit Triangle. Go ahead. So, this group is your group. It's a group to kind of share information, learn, and kind of focus ideas and practices that make your lives easier. So, it focuses on Revit, but there's so many other things to talk about, and we're going to be looking about that today. So, last one. And the group is run by a board of advisors. I'm one of them. There's a few of them also here today. Dana DeFlippi, Ava Norton's here. Rob's over there as well. Andy, there's a lot of speakers here that you're going to see that are all related. So, a lot of hard work goes into making sure these presentations are applicable to you and useful for you all. All right. And so the one thing that we ask of you, other than your attendance, which we've already got here today, is that after the meeting, please fill out the survey. If you have a class you would love to talk or a presentation you would like to give, please fill it out. Let us know. If you like things about today, fill it out. Let us know. It's real easy, but we really use that information to kind of craft and guide what we're doing in each of the Revit user meetings. Okay. And lastly but not least is our agenda. And we've got some really good speakers with a lot of different techniques. So we're going to start out first with Andy Schrader from WSP. This has been a tried and true presentation and updated. So really cool about using Revit and Dynamo. A really nice one from Julien Bartolo and Chris Twilley from Davis Construction. Okay, a whole bunch of all fun tools. I even see the laser scanner here. Especially, I'm looking for the GPR, the ground penetrating radar. So I'm looking forward to that. And then last but not least, David First is going to talk about, a practical way to use augmented reality. A lot of those are fun tools that we play with and we think they're cool. They're more like kids' toys, but what can we do with them? And David's come up with some really great ways to use augmented reality. So I'm looking forward to tonight. I'm glad everybody is here. And with no further ado, Andy Schrader.
All right, awesome. Hello, my name is Andy Schrader. Like Galen said, I'm a WSP and a BIM manager, so I'll move on from that. Tonight, I want to go through this process for getting your clashes back into Revit. It's a process I've done a bunch of different ways, but this way I'm going to show tonight is pretty neat. It's very simple. It's basically creating one parameter, some view filters, using view templates, the interference checker, a multi-category schedule, and running a Dynamo graph, a simple Dynamo graph. Just polling the crowd here tonight. How many people do clash detection in their office? All right, awesome. How many people use Dynamo? Perfect, awesome. All right, with no further ado, let's get going because I got 25 minutes and a lot of stuff to cover. So I'll try to go fast but not too fast. If you'll save your questions to the very end, I am going to be here the rest of the night. So if you want to approach afterward, great. So here we are in a Revit model that we're going to do some clash detection on. It is a football stadium. And so you can see what it looks like. On the MEP side, which is the arena that I work in, it's going to look something more like this. So as we can see, I've got the architecture turned off because for this purposes, I'm just going to do structure, which is what we're pretty concerned about while we're doing our MEP modeling. Here we can see everything that's in here. We've color-coded the mechanical, electrical, and plumbing. The HVAC is green, the electrical is red, the plumbing is magenta, and technology is blue. All right. How many people out there use the interference checker? Perfect. Awesome. So this tool has been in existence for a long time, and I feel like it's really lacked a lot of functionality. It's lacked a lot of really, some things could really be added to it to make it awesome. Because if you're doing clash detection, a lot of us probably go to Navisworks or some other platform to do clash detection. And so it was awesome when I learned Revit that, oh, clash detection's in the model. Oh, it's not that great. With that, tonight, hopefully I can persuade you with this process to possibly use it. So what we'll take here is, first thing that we're going to do is go create a project parameter. Because what we want to do is grab those elements. We're going to do a clash detection which says that I've got this element is clashing with this element, right? And we know that Revit is a graphical database, so it's going to assign those things a number. We're going to capture that number and then put those elements together. Simple as that. So what we want to do first is be able to label those elements. So we'll come down and create a project parameter. And I've already created it, but I want to talk through what's unique about this. We gave it a name, clash detected, and we've given it the type of parameter as text. I used to use the yes/no parameter because that worked perfect in my mind, because does it need clash or is it not clashing, yes or no? But the functionality of whether it is in a group or not in a group, you can't manipulate yes, no if it is within a group. So using text, I can do that outside of that group, which is the reason I switched over to a text. Then I'm going to come over to the categories. You have all these different categories in your Revit model. What I want to do is just grab the ones that I'm going to see in a 3D view and that I'm worried about with the clash detection. So you can see I've got these checked: air terminals, cable trays, and the unique thing that I want to leave out of this are the things that are already grouped together. So like a cable tray run. A cable tray run is fittings and cable trays that are put together into a group. So if I've already got them independently, I don't need that system, that run. So you'll see with the cable tray runs, the conduit runs, the duct systems, I don't need those because I've already picked out those parts independently by having duct accessories, duct fittings, and ducts. So we'll go through here and check all of those items that you're going to see in a 3D view. There's things that you don't need checked in, that you don't want extra parameters lingering within that family, like grids or zones or levels or what have you. So essentially what I've gone through is just check those items that we're going to see in the 3D view. All right. Perfect. So we've got that parameter checked. The next thing that I'm going to do for this particular process is go create a filter. Since I've just gone through that process of trying to figure out what I'm going to see in a 3D view, this kind of makes sense to lead right into that. I'm going to create a filter that is looking at those. So once they come into my model, I can do something when they have this particular text value that I'm going to assign to them. So with the clash detected, this is kind of strange if you look at it. Hopefully everybody can see that because I can't do anything else about that. But so we're going to label this clash detected, really common name so that we can pick it out of crowd. We're going to go over to the categories that we see right here and select all of those same elements that we just picked in that family parameter or that project parameter. And then you'll notice if you happen to grab something outside of those boundaries, you're going to get this message that says, hey, wait just a second. That wasn't in that list that we were just looking at. Are you sure you want to continue? So I can back out of that without ruining this whole list. Then we're going to assign that particular parameter, that project parameter, a value that does not, very important, does not equal y. So we're going to assign this y, meaning yes, this is an element that is clashing. And the reason that we want to do that is because we're going to use it as a filter. So we're looking for all of those things that are not clashing so that we can then turn them off. So it's kind of the inverse of what you might be thinking. Then we have another one. So now we've just created that. We're going to duplicate this. We're going to call it highlight. And with highlight, what we want to do is make this thing shine among all the other things that are not clashing. So then that way we can see what parts and pieces are clashing with the other elements within our model. All right, does that make some sense? You'll see when I get All right, perfect. So that part's set up. The next thing that we want to do is jump over to the interference checker. So if you've used the interference checker before, you can run the interference check, and the way that we're going to do that is just select these elements within our model, just like so. And the nice thing about this portion is that I'm not doing my whole model. I can grab parts and pieces out of my model. So if I'm doing a particular amenity space or something like that, I can focus in on that. Whereas if I was in Navisworks, I would have to do a lot more setting up of a particular region. All right. So we're looking at 4,354 elements that I'm holding on to. I'll jump back over to the Collaborate tab and go to my interference check and run an interference report. So if you've never seen this before, it's column A versus column B. And all the things that I have selected over on the left versus the same things that I'm looking over on the right. Well, for this particular clash, I'm going to do my MEP versus my structure. So I'm going to change the second column to my structure model. And I will select the items that I'm concerned with here, columns, foundations, and framing. And I'll say, OK. Once again, if you've never seen this before, wow, that's pretty cool. I can do that. Well, then I get this dialog box. And this is where the unfriendly portion of this dialog comes through, is that it's nice that it tells me all of these things, but then I have to do a lot of clicking to actually get this data to do something for me. So if you open this up, for instance, I can see that I have an air terminal clashing with this particular beam, but it's a lot of work to go through all of these clashes. And right off the bat, I don't even know how many clashes I have. So the way around this is we're going to export this. So if you export, this is going to make an HTML. And we will go throw that into a nice folder that we've pre-baked. And we'll call this Clash, and we'll put a date with it to 12/19. Awesome. All right. So very quickly, we've done our clash. That data is sitting somewhere else, and I'm going to close out of this. So. All right, come on, get my model back. Just to kind of show that there's no smoke and mirrors here, we have a schedule that we created that is looking at these elements. So essentially with this is we're creating this multi-category schedule, and it's just pulling out whether that family is on a particular level, what the family and type is so we can see what it is, and whether that value is clash detected. Remember, we're going to assign it a value. Haven't assigned it yet. And then we're just filtering by all of those elements that have this value. So we're going to access that. All right, perfect. So now we've done all that. Let's jump over to Dynamo. So we'll go to our I'm going to use 1.33. Anybody not know what Dynamo is? All right, perfect, awesome. I will take that as I totally know what that is. All right, so I've got it right here. I'll open that file up. And it looks like this. So as you can see, it's not super huge. The first thing that we're going to want to do is point to that HTML that we just set up. So I go back to my folder. There's my clash, and I'll open that up. So now I'm path to there. What's the rest of this stuff do? Well, I'm going to look in that file, and I'm going to use this package called Spring Nodes, and it's going to pull that data over, and then it's going to fetch those items within an HTML that's broken out into a crazy structure, if you've ever opened up one of those before. And I don't know programming enough to decipher why it's all spaced out like that. But then you've got all of this data that you could pull out of that. So clash categories, affected elements, unique cases, number of clashes. That's going to make a list for me. And so if you'll remember, I had column 1 and column 2 out of that. And I'm going to separate out those columns so I can pull that data into my model. So I'll just run this so that we can talk about it. Boom. All right. So here's my list right here. And you can see that there's list 0 and list 1. So that's 1 and 2. And what I'm going to do out of this get items out of index is I want all the items out of 0, which was my MEP. If you remember the first column on there were all my MEP objects, all the other ones were the structure. So for this first take, I'm going to do the MEP objects. And then grab those unique elements, and you can see that they're green over here, so they're live within my Revit model. Perfect. So just like that, move this piece. All right. So I've already run it. And now we'll see that now the schedule is populated with all of this stuff in our model. Perfect. So let's go back to my clash views. And I'm using a temporary view property. I'll take that off. And here we go. We are now showing these elements within the model that are clashing with that element in my linked model, the structure. So right here, you can see that value has been given a Y. So I'm just filtering out those elements in this view that have a Y. And I've turned off all the other elements that don't have a Y. So we can see them. But now you're wondering, wow, what about all the elements from my linked model, right? That's what we're all thinking. Oh, great. Awesome. So now we're just going to do the inverse of that. And the way that we're going to do that is set up our structure model. This is the model that's linked in that we got from our structure. And the nice thing about this is that we don't have to go through all the work that we just went through. I'm going to take this schedule that shows all the stuff that I need. I'm going to right-click, copy, go to my structure model, turn around, and open that up. Boom. All right. Awesome. So now within the project browser, since I'm holding that onto my clipboard, I'll click in the project browser, go up to my modify tab, and I can paste that schedule into this linked model. It gives me the schedule, what it went through and did. Also behind the scenes, whether you didn't know this or not, it created that parameter, that project parameter that I went through and had to go through all the categories and do all that stuff. So I didn't have to redo all of that, which is great. Time saver. So now what I want to use is Dynamo, because I still have all those values. Everything's on the opposite side. And if you'll remember, or if you've ever used Dynamo, you can only use Dynamo in the same session that it's been opened up in. So now I'm in a separate session, a different model. I got to close out of this. So I will save this to keep all my paths. Close that up, turn around, open it up again. It's sitting right there. And then I will run that. Uh-oh. Oh, silly Andy. All right. So I just ran it by accident, and I remembered that, remember, column 1 is MEP, column 2 is structure. I got to change this value from 0 to 1 so that I'm looking at the correct list of elements. So now when I run that, different set of elements. Here, they're over here green. And my schedule's populated. Ta-da! Awesome. All right, tough crowd. All right, so I'm gonna save this. All right. So I'll save this model. Just like that, I'm done. I don't have to do anything. I don't have to go explore the structure model, figure out what's turned on. I can visually see it from the list. I'll close this. Close this. Now I'm back in my MEP model, and I'll reload that link. Boom. All right. So now I am only seeing those elements that match that criteria that I'm looking for, right? I've signed yes to my structure and my MEP elements. And in this view, I'm only showing those elements that say, yes, I'm clashing. So ultimately, through this process, you should be able to see everything that's clashing through that. All right. Wow. Awesome. Great. All right. Awesome. So what else? Thank you. So what else can we do with this data? Let me check my time. That we have. So this is great. It's in a 3D view. But how can we utilize the fact that we now have all of our clash data visible within our model? We're looking at it in a 3D view because it's fun. Let's go check out a floor plan, wherever I put those. So in a mechanical plan, we've done something like this. Can everybody see that all right? So with a view template, now I'll come over here, show you what the view templates look like. I am using a clash detection highlight, and I am overriding that value so that it's 9. Yeah, how many people use 9 in their Revit models? Of course you don't. So I made it 9 because that way everybody's going to see it. And then I gave it a dash just in case that somebody's using some other type of line work that would make that stand out. So now we have 2 things that's going to make this thing stand out in a view. One, it's really bold and annoying, and it's dashed when it probably is going to be a continuous line anyway. All right. So now we can see those, right? That's pretty cool. We can see that. We can now create sheets. We can create coordination sets. We can do so much stuff. One of the fun things about Revit and some of the newer features is being able to select this element, and then we have the selection box up here. So I can say, what am I clashing with? Then I now have a 3D view that is showing, and it's kind of hard to see because it's so bold, but if I turn this to thick thin, I'm running into these pieces up here. And so now I can navigate through the project by closing this out, going to another piece. I'll turn that back on so you can see it. Let's jump to the other side and see. I thought there was one over there. We'll grab this VAV box. We'll see what we're. All right. So now we can. Here, I'll turn that back off so you can see that clearance is running into that beam. But now we can use this tool, and this is inside of here. So what else could we do with this now that I've got a couple minutes left? Is create plans. We could add another parameter. It throws a date on there or something like that so we can kind of track what happens to this value, whether it got updated or didn't get updated. We can take 3D views like this and publish them off to BIM 360, Glue, or somewhere else so that maybe a project manager or somebody else that's not savvy within the product actually can see what's going on in that model and see those elements. I'll jump over to a plumbing view just so that you don't think I'm. All right. So let's see, do we grab any plumbing out of here? With that clash test, I might not have, oh, there it looks like there's something right there. All right. So once again, I'll use that section box and then spin that around and see that we're running into, boop, we're just grazing that beam right there. All right. So that is how we can get our clash into the Revit model. And so what do we do after that? What if we're about to print and you don't want to print your set with all that stuff on it, right? That would look crazy. What we'll do is we'll create a schedule. One, you could create the filter and not apply it to the view. Of course, you could do that. Or if you wanted to just create a schedule, and these are all of those elements, I'll just make this not itemize all the instances. And I will delete that value. So now they're all gone. And if I go back to another plan, everything's back to normal. No big whoop. But I still have captured all of that data within that HTML file, and it's timestamped. So if I need to clean it up and then I want to pull that all back into the model, I've got it. It just takes a quick second. So, all right. Boom. There we go. How about that? Did I make my time? All right.
Does anybody have any questions?
Uh-oh.
Let's do one here, and then I'll work over. You guys can use the mic.
Can you share that Dynamo script with me?
Sure, absolutely. There's nothing special about it. So
Does that answer the other questions we saw? Okay. All right.
now there's a way. I just use the interference checker because it's free. Yeah, everybody loves free. Dynamo's free, and interference checker's free. But the same process, the same concept can be done with Navisworks and pulling that data. Because what we're getting from Navisworks are those element IDs, and just pulling that data back through Dynamo and funneling that into your Revit model.
Are there tolerances for the clashing within that setting?
Not with the interference checker. It's all hard clashes.
And then do you have to model your clearances for MEP stuff a certain way to?
Well, they're
get a
tied to
clash
that
or-
model. They're tied to that model, to the mechanical element.
Anyone else?
There's one in the back.
Wait in the back. That's gonna be loud.
Hello. Is this setup one-time setup and it's going to be dynamically updated if I fix the clash, or is it I have to run the script every time I fix the clashes?
Great question. If you fix that clash, that element still is branded with that value Y. So yes, you would need to clear it out and rerun it again for it to not have that value.
There you go.
Thank you. Have you tweaked the inputs so they work through the Dynamo player?
I have not, but it's completely possible.
Right.
There's nothing special about what we're doing. You're just pathing to a file. And good question.
I saw that you had to delete one of the columns from your schedule to undo what you did. Is there a way you try to work it where you can have a specific view and just call it clash detection view and use the filters so it's only visible in that view? So this way,
Absolutely.
you
Yep.
could do that.
Yeah.
Okay. Yeah. I was trying to think about that.
You
so
can create a
I don't have to
Dynamo
delete it.
script in your player, one that runs the clash detection, one that wipes it all out.
All right.
Great questions.
Well, good. Thank you very much, Andy.
All right. Thank
All
you.
right. Next up, guys. Good job.
All right, okay. We are golden, back on track. Sorry about that, guys. So anyhow, Davis Construction, we'll talk a little bit about who we are, talk about the in-house GPR, 3D coordination, reality capture. We are on the general contractor side. So we basically manage every single division, every single trade. We make your designs, a lot of you engineers and architects come to life from scratch, which can be very challenging at times, but we try to use every piece of technology we can to our benefit. And then, lessons learned along the way, try to make things better for everybody. So with that said, a little bit about Davis. We are a local national general contractor. We work Maryland, DC, Virginia. Those are our primary stumping grounds. But we do compete with a lot of national, international firms. We've been ranked one of the top 25 general contractors. And we've, number 89 in the top 400 in ENR. So we get to work on a lot of awesome projects around the area. And like I said, we're mainly local. We've been here for quite a number of years. We're about 400 employees strong. We always have about 70 to 80, 90 projects ongoing at one time. And we've been in business for about 52 years now. With regards to market sectors, we pretty much work on just about every single market sector, some more than others, obviously. But that's one of the things I've loved about what I do is I'm exposed to just about every single different market sector out there. So these are just some examples of some of the projects we've worked on. Some are still sort of ongoing. Top left, 655 New York Avenue. I'm sure some of you guys are pretty familiar with these projects. Again, office buildings, just to kind of quickly give you an idea, renovation projects, which is what we'll talk about today. Uline Arena, 2000 L Street, I believe. No. 2000K. So we do a lot of these renovation projects, which is what today's presentation will be about. Do a lot of interior work for a lot of different clients. Institutional work as well. Canal Park, Madame Tussauds, National Cathedral, restoration work after the earthquake. Then we do a lot of education work for a lot of different clients, including Georgetown University right down the street, a couple others. And we do a lot in healthcare as well. All right, so how do we use all these different technologies to our advantage? A lot of times before we chalk the first line or turn dirt, we've already figured out many issues virtually. And I'm very appreciative of the fact that some of you guys are using the clash detection within Revit. It definitely helps us on our end. We definitely go through our fair share of clashes, but anything that you guys can do to help us, obviously it definitely helps move the process along. So the project we'll talk about today is 1900 Half Street down in Southwest. Like I said, we'll talk about it's a commercial to residential project, and we're using a lot of different technologies on this project, as well as new initiatives based on lessons learned, which we'll talk about here in more detail. So a little bit about the project itself. It was previously an existing 700,000 square foot office building. It is now being converted into a 580,000 square foot mixed use retail residential building. It has 2 levels of below grade parking. Eventually it will have retail on the ground level, and it'll consist of 453 apartment units, and they're currently going for LEED Gold. These are just a couple pictures of what it will ultimately end up looking like. Location-wise, it is literally across the street from the new DC United Stadium, the Audi Stadium, right on the water. Pretty prime location. Here's a rendering of where it is actually located on site. It is, when I first saw it, it definitely was in need of a little love. It was not pretty at all, but we will make it beautiful yet. So one of the things that I really found very interesting once we started this project was, typically, so I mentioned a little bit ago, it's going from 700,000 square feet to 580,000. Usually, a lot of our designers and owners try to add square footage. This owner decided to reduce the square footage, and you'll see here in a bit. The reason why is the way that they shape the building. Nearly everybody will have waterfront views, or at least water view. So reducing the square footage, but yet selling a better product. So that was one of the ideas. So with regards to the, how do you go from a previously commercial building to a residential building? That's been one of our very difficult challenges over the years, and every single project we have worked on, Orinoco, 225 North Calvert up in Baltimore. So a lot of these commercial buildings being converted into residential apartments, condos, very tough. Everybody wants the LEED credits. So they're not just demoing buildings down to the ground anymore. They're trying to basically gut the building and then reuse as much as we can, which is perfectly fine. But the challenges still exist. So on a typical project of this type, between 3,000 and 8,000 slab penetrations is not uncommon. So for this particular project we're talking about today, I believe we are over 6,000 new core penetrations, duct risers and so forth. Every location is unique. I believe our building is not PT in this case. It is just mild rebar. But regardless, you're going to have PT cables, you're going to have rebar, you're going to have conduits, embeds, walker duct. You're going to have all kinds of different scenarios that are obviously not visible to the eye. So there's a lot of different things you can do, different technologies, different steps. Eventually, you will have to core drill in order to succeed on these projects. So the question is, how do you go from design to the actual core and do it successfully and somehow still maintain everything within the coordination effort? So there's a few different pieces of technology out there that you can use these days. You can look at as-built drawings. Everybody still does that, which is fine. You can kind of review the existing structures, figure out field non-destructive testing. There's ferroscanners, there's x-rays, pros and cons. Some are definitely better than others, different requirements. The one we're going to talk about today is actually the ground penetrating radar, which is the one on the far right. So typical coordination process, typical as in what we've seen or done in past years. We figure out all these core locations, which then get marked in the field by the subcontractors. So we're the general contractor. Our plumbers and everybody else would literally go out to the field. That's in your scope of work. Go lay it out. So they would go through. That would be sort of step 1 or 2. That individual would then call or contact a third-party GPR consultant. They're out there, we all know. So then a little bit more time goes by. That trade would come out and physically mark on a slab, top bar, bottom bar, as well as where the how they relate to the proposed core penetrations. Oops. And then ultimately, what ends up happening on our end, or what was happening before, and this is one of our actual past projects. We would then get a report from that subcontractor, so there's a little bit more time. The GPR consultant needs to put a report together, gives it to the plumber. They look at it, they send it to us. You're talking weeks, sometimes a month before you get these reports. And what you see on the far right there is one of our previously RFI 51. The one that's highlighted is actually revision 11, but every single one of those folders relates back to RFI 51, which was designated as the RFI number, which would track every single core. Okay, so there's, I think there were more, but I'm up to 15.1 at the very bottom. And they all relate to cores, different levels, different areas, different core numbers. So the RFI on the left-hand side here is one single RFI, which is RFI 51.11, and it consists of 143 pages. So in other words, 143 cores in the one single RFI. Just like I said earlier, there will be thousands of cores. The question is, how do you efficiently manage this process, right? So now you have these massive RFIs. You have physical layout in the field, and then you get this. Then you get somebody's out there laying out these cores, diameters. They put it together on a PDF, which is fine. I mean, you're sharing information. There's the north arrow. The problem really comes when things get shifted. So you lay out per design. If it doesn't get relocated, that's not a problem. Once things start shifting around and people are making adjustments in the PDF, we start losing valuable information. I don't have the time to go into a 143-page RFI every single week and sort of track, where is this on plan? Which way did it shift? So you start losing very precious information. And what ended up happening through this process was our models basically became invalid very quickly. So in other words, we were getting calls from the field, why is the riser through the duct? And we're looking at the model, and well, the riser is not through the duct. Well, apparently that core shifted at some point in time. Nobody knew where it shifted to or how it shifted, so the models just became useless. So this was a challenge on numerous projects. And basically, sort of as lessons learned, we've come up with a new way of, a new initiative on trying to, maybe new opportunities on trying to do this better, basically. So thinking a little bit outside the box. So what we've done now on this particular project with our design teams and all these other professionals is we've basically established a structural modification guideline. Where can you core, where can you not core? If you're in this area, you can cut this many top bar, or none at all, or maybe one bottom bar, that kind of thing. So we have a set of rules and guidelines based on the structure that we are working with. We then basically take all the in-house technology with regards to the robotic total stations. I don't know if everybody's familiar with the total stations. So everything is based off of an XYZ point coordinate value. And they're not necessarily robots. They're basically, they assist us with point layout, properly laying out points in the field with regards to how they relate from the drawings that we have in-house. We then capture this GPR data, the ground penetrating radar information, and we now incorporate that into our Navisworks model. So what you see there is an example of an actual. It's actually kind of a bad scan. This was one when we were testing, but it's generating 3D images of the actual top-bottom rebar, and the yellow is the 3D cores from the plumbers, and then the red sphere you see are the actual points from the field. So we'll get into that here in a little bit further down the line. And then lastly, we saw this once we started studying this process. Just like I mentioned earlier, there were so many. We literally sort of went through a pool planning session about this whole process. And we figured there was so many individuals involved and so much time lost in the process that when we started looking at it, we chose to basically take full ownership of the entire process, literally from start to finish. So traditionally, lay out the core locations in the field. The plumber used to do that. The GPR scanning was done by somebody else. The GPR data processing and the RFIs, the plumber would send that to Davis. And then the core drilling would be another trade. So now we basically perform all the layout in the field. We manage and perform all of the GPR scanning. We also manage and complete all of the submissions. And we also own in our scope the core drilling subcontractor. So we manage everybody, start to finish, and in between. All right, so when it comes to the overall process, when I said that we put together sort of a pool planning session, so myself and a number of different individuals, based on lessons learned and past experiences, we basically kind of peeled this whole thing back and said, all right, where do we typically start, and where do we need to go, and what happens in between, and how can we sort of better facilitate this process? So one of our structural engineers actually is in the room somewhere. There she is. Jennifer, but so we actually, one of the first things we did was, we put our before this project started, we put our thoughts together, and then very early on, we actually presented to the owner and design team on what, this new initiative based on lessons learned in the past, we wanted to do something different. And this is actually something that we presented to everybody, and everybody was on board, and it's an ongoing process, and it's actually going fairly well. It's not perfect by any means, but we were definitely doing much better than what we used to. At least I'd like to think so. So with regards to the actual process, I'm sure a lot of you who are on the submittal review or design side have seen submittals come through. There's really nothing too special about these submissions. This is an annotated PDF. Everybody is color-coded. Each trade has its own designated color. And if we zoom in a little bit, you'll kind of see a little bit more of this information. So green would be electrical, blue is the plumber, magenta, we don't have too much here, is the duct risers, and then red would be sprinkler, but in this case, some of these other cores are kind of unique, so they're also isolated as such. Orange is the existing. And then you'll see, I don't know if you can see my mouse, yes, you can actually. So each one of these cores, it's kind of hard to tell, but they each have a unique identifying number. So every single core on this project, we know where it is, what its location is, XYZ, diameter, thickness of the slab, and all that sort of information, as well as how it relates to what is in that slab for that specific core. So here's a sample of, so this is our submission that we initially put together within my group or in operations. It then goes to the field where the, where the layout engineers basically perform the GPR in-house, and then they perform an in-house review as well prior to submitting to the structural engineer. So we performed the first pass based on what we've seen, and this is a close-up of it. So when the structural engineer gets these documents, we provide a complete package, inclusive of all electronic files, because another challenge we had in the past was when a core is individually relocated in the field, if you're looking at those GPR marks on the slab, it's very hard sometimes for the designer to determine, should I shift that whole wall 40 feet down the line, or should I just deal with this one core? So providing everything electronically to the design team allows them to study if a core needs to be relocated. Here's your plan overall. If you need to relocate a whole wall, it's a lot easier to kind of share and discuss that information. In this particular case, these are hyperlinked PDFs. So everything you see here is done by Davis. The structural engineer gets these documents. There's a little hand there. When you hover over a specific core, it's going to bring up a very specific GPR report. That report will pop up, and you'll get a top and bottom rebar report, which it's kind of hard to tell, but it'll actually include the core locations as well. All right, so that's kind of a sample. So Profesh is a Hilti piece of software that we've actually, so this is kind of the new component that's come into play from our end in order to facilitate this process. So Profesh is a Hilti component. We purchased the equipment, we were trained, and we now incorporate it into our process, basically. So we've eliminated sort of, not necessarily eliminated, but we've sort of eliminated a lot of the in-between and the time lost, and we just took ownership of the actual process from start to finish. So with regards to the return submittals, so this is what comes back to us from a sample. Here's a blow-up. So what we do with these documents when we get them back, and you'll notice here real quick, so the new structure is going to be shaped like a number 3 or a letter E. So the whole idea behind this was to capture and approve as close to 100% of these cores by zone. Another struggle we've had in the past on a lot of projects is the fact that cores get lost in transmission, in the RFI, the superintendent can't close certain walls. It's a total chaos last minute. So we wanted to basically focus 100% on each zone and capture as many, well, the idea is to capture all 100% of the cores before moving on to the next zone, or at least having the knowledge of which cores need to be further evaluated. So when these submittals come back to us, we, in Bluebeam, we can do a very quick search depending on the comments that come back. And what we've seen happen, there was definitely a learning curve. We've done, I want to say 7 or 8 levels of zone 1 thus far, and it is an ongoing process. And now that things are starting to settle down, I mean, it's typically, I want to say maybe 10 to 15% of the cores. So we submit about 200, I'll say close to 200, 210 cores per zone. And we're seeing about 10% of those come back with either we couldn't get to them because of material stock or access, or the structural engineer might have a question about further clarify this and that. So we're seeing about 10%, 20 cores, 20 or less come back with regards to in need of further addressing. All right, so how do we incorporate all this together into Navisworks, which is what we use? So obviously, we're not going to talk much about clash detection, MEP. We're doing all that already. This is sort of a further step. And what you see here is basically all we're doing is we're asking our trades to annotate their files early. So obviously, we have a certain diameter system coming into play. We really want to know what core diameter do you need for that system. So if you have a 6-inch pipe, do you need an 8-inch core? That's what the structural engineer wants to see. So we had them provide us with fully annotated drawings early, 3-dimensional cores. And then what's happening is, since we're doing all the layout, every point number you see noted here in blue, for example, comes from the Davis field engineers. We use APL to pull in those text files, and then we give the points a call it volume and a color. So we make them a red sphere. You'll notice here on the right, 0.9016, there's definitely something wrong. So the sleeve is actually west of the shot that we took in the field. But you'll also notice that there is a note that said moved 3 inches. So as a result of the GPR review process, the core was relocated 3 inches to the west. The annotated documents are updated, and now Davis can easily see that change. So now, after the fact, we'll go through in the field and do a sort of a cleanup process of these levels. And I'll show you a couple more examples here. So this was the electrical, so the red represents the initial layout, which for some reason, I think there was some discrepancy or misunderstanding when we first submitted. The initial layout was incorrect, which is what you see in the red. The blue or cyan color is actually the new layout with the cores further spread out. So now again, Davis will just go back and reshoot those points, and everything will be in the right location. Excuse me. Here's another example, kind of hard to see. So moved 4 inches, and it's all bubbled. So this is the information that we were missing on those other prior projects where things would shift, but we had no idea where they shifted to, which then made the models useless. Now we can adjust these cores. The plumbers are adjusting their risers in their models, and everything is pretty much falling into place. So I'll pass it on to Chris now, and we'll talk briefly about the laser scanning process.
Anybody in the room work with laser scanners? Okay. Just within the point clouds or actually in the field. This new unit from Leica, I was number 3 in North America to get it here at Davis. So got a good working relationship with them. We were utilizing a C10 unit. And for some of you know, it was a dinosaur. I mean, it was carrying around, cinder blocks. And with this unit here, we're able to get in and out. The time is cut down tremendously, and the accuracy and precision that this unit is possible of is unbelievable. It will spend 26 seconds inside of here, and it'll capture 2 million points per second. So what you see in the picture here is not far from what you would digitally see once you would scan it and import it into a drawing. It does do the photography, and the nice thing about it is it does recognize like georeference targets. So we'll establish our targets within this room. We can scan it, and the software then recognizes where we are. So then we can incorporate it into our coordinated model. Yeah. So furthermore, with this unit here, it has the capability of tracking its local. Get more? It has the capability of tracking. It has 6 cameras, so as you walk, you are able to then position yourself on the other side of the wall. The technology is probably, I would say, 7 years ahead of other scanning developers, just for the simple fact that it references and it sees where you're going. And it just makes it so useful and helpful in the conditions that we're in. There might be existing conditions where it's wide open, but then we might be in the middle of a demo phase that we need to come in and scan the plenum space, or we're looking at floor deviation maps, or we're looking at mechanical rooms because we want to do some improvements. So being able to run around the project with this thing it's simply amazing. So 3D coordination is what we use this for. This is 1900 Half Street, what Julien was just talking about. This is one of the floors. We are in the demo phase, and so we were able to scan the existing conditions. And this is great in space, but we're locked in to a grid system, so we're all on the same page. So when everything starts coming in, we'll drop in the plan that Julien has, and you can quickly see the field engineer's control points and the cores that are ready to be laid out. His spheres come in, right? So we're able to go and show, hey, there's that point with the sphere. There's the core that needs to be relocated. So everything starts coming into play. On here, I don't have the colorization as far as for deviation, but we're really worried about that plenum space. There's a very limited amount of space up there for all the mechanical equipment to go in. So we're able to start seeing where, there's some deviation in the floors and in the ceilings that are going to interrupt our trade. So we're ahead. We're able to tell everybody, hey, we need to start looking at this. We might need to make some modifications. We might have to create a bulkhead, or what might have to be done, right? So then, the mechanical stuff slowly coming in here. You can see there's an existing drain there. So it winds up running through one of the mechanical components there. So we have all this stuff together locked in, and at any time we can send somebody back out there. Once the trades begin to work, we're able to go back out and scan, and we're able to do our QA, QC on that as well. So it's using every piece of technology out there and precise measures to make it happen, but that's where we differentiate from others. So we use it pre-planning. We have a project in Rockville that we're working on, and so we went out, we scanned the site. The the civil drawings are mind-blowing, lines everywhere. If you can quickly look over existing new storm drains to go in, are these new telephone lines, just Verizon. There's just a whole bunch of stuff going on for this lab. And so we locked it in as far as our grids and our coordinations, and we're able to bring in the new building. So we've got the scan. There's the new building that's going to be going into place. But the building over here, this is a modular unit, and this modular unit houses a lot of equipment that can't be disturbed until the new building's done. Well, we have storm drains that need to run through, and we actually have to dodge around this modular unit just temporarily until we get the new building done, and then move everything over. So we brought the civil stuff in, and there's a bio retention area inside of the curb in this red shaded area. So underneath this, we have all the civil created in 3D as well. So we can quickly see and we can quickly discuss with our team members, hey, this stair right here in this modular unit, there's an issue there. There's a 10-foot cut. We need to, figure out a new egress for them. So it's just being ahead instead of standing there and losing precious time, right? So we use it for custom designs. This is a synagogue downtown. I don't know if anybody of you been in there, 6th and I, but amazing place. This is the point cloud with the photos. That's all it is. And so each individual point has a color associated with it. And we needed to create sprinkler lines and mains, and they wanted to follow the contours of the ceiling. Well, there's no real drawings from that building, and if there were, you still need to get up there and field measure. We went in there less than 2 or 3 hours with this unit, captured everything, and then we were able to then trace out where they wanted that fire mains and the sprinkler lines to go in, and be able to create those CAD drawings and produce. So now that these pipes are being put in production, and be able to come back in and land everything accordingly. Just a lot of this. I would love to show you guys this. I mean, the picture in the back, the glass. There's a big cathedral. It just captured everything. It's pretty amazing. So we also use it for our deviation surveys. This floor plan here was for a studio's ABC News. And so the deviation survey here, you might be confused about it, but the red is bad, okay? We can all understand that. So the green's good and the red's bad. So we have just, mid-bay deviations up to 2.5 inches, and the owner wanted to come in and level everything. So it was a little extensive, but we were able to do 1/4 inch, and we were able to go in there and level it up, and be able to figure out cost and time and all that good stuff. And actually, it's a big part of what we do in a lot of the different sectors that we work in. The one here on the right is a wall deviation survey. So we have a project that the neighboring structure has a slight lean into our project. It's been like that for years. We were able to come in and scan, and you can see this yellow here turning to blue, turning to red. This is a little small down here, but it has a natural lean about 3 inches into our area there. So we have, our monitoring efforts that we keep in place on that. But the biggest thing is down here, there was some underpinning and a new style of a
Soil remediation.
Yeah, soil remediation. And it's coming into our foundation wall. So we were able to scan this say, okay, guys, we're gonna have to chip this back a little bit. Just keep everything rolling. And we're probably, I would say, 2 or 3 months away from that point, but at least we have a game plan and we're moving forward.
All right, so real quick, lessons learned. I know we're running out of time here real quick. So lessons learned, so some of us see it as a problem, some of us see it as an opportunity. We try to harvest all these lessons learned and find better ways to sort of better our end deliverables, which is in this case a building. So with regards to the overall process, it was a totally new initiative within Davis. We always see the behavioral changes as a challenge internally. I don't know if it's just strictly related to the area we're in, and I feel like out west, a lot of people are more open to some of these changes. But we've gone through that. We've gone through our initial upfront learning curve, and we're starting to see some of the fruitation out of the process. Anticipated workflows, if anybody tries to jump into this, lesson learned, clearly communicate your plan early and stick to your plan. So we went through a couple of, and when I say we, I'm talking, higher ups in the operations side gave us direction, and then it changed, and we're the ones dealing with the trades, and it's just easier to sort of be on the same page from day one and just stick with it and kind of run with it. So if you do come up with a plan early, just try to stick to that plan. Making sure that your trades always work from the latest and greatest documents. I know that we tend to be obnoxious sometimes from the general contractor side, asking for these Revit model updates and addendums, and you guys might not think that it's as important as we think it is sometimes, but making sure that we have the latest and greatest information on hand at all times definitely helps us help you get to the finish line with again, a better product. Big shift in liability on our end. We studied this quite extensively, dollars and liability and, the process time. We're taking a risk, and we're taking a lot of risk on this one with regards to, initial layout, for example, versus relocated cores. Who's going to do that? Making sure that you have your scope gaps all covered. Structural review, something as simple as that. So we performed the initial structural review. We don't just send these documents to the structural engineer and tell them good luck, we'll hear back in 5 days. We take, that's part of the agreement. We go through it first pass. We try our best. We're not professional engineers, but we basically communicate our findings and question what we can. Excuse me. Another big one, resource allocation. Making sure that you have all your resources properly allocated, making sure that your teams internally understand if we're going to go through with this, we should have a designated team, and that is strictly what they're going to be doing. People getting pulled in 100 different directions to do other layout requirements. Next thing you know, somebody's questioning why did it not take a week like we talked about, and now it's been 3 weeks. So proper resource allocation is critical. Access to the site, obviously, making sure your slabs are clean, accessible, material stock. So there's a lot of sort of pre-planning that needs to go into this. With regards to other lessons learned, I would say project size, maybe taking that into consideration. As much as I love the fact that we are doing it on this project, it has been a challenge to sort of keep up with all the requirements. I feel like if we would have maybe taken on a 200-300 core project, a lot of people would have had a much more enjoyable upfront experience with the process. It's been hard to keep up with demand, so it's happening, but I feel like some people have seen that as a struggle. Future design changes, how do you incorporate that? Who captures those? Equipment failures, we've had them. GPR unit broke down. We lost almost a week. So having a plan of action when that happens, who do you call? How quickly can we get it? Do we buy another unit? Weather delays. I had never even thought about this one, but guess what? When it rains, the slab absorbs all the moisture. You can't just squeegee it and come back the next day. That moisture is embedded in the slab, so your GPR scans are now distorted. But how do you control that? I mean, so again, just talking about it up front, making sure everybody understands the time of year, and then construction traffic in general. The layout engineers do a lot of layout, and then it kind of saddens me sometimes when you go out there and then the skid steer deleted it all, or now you have to do it again, and so there's a lot of sort of variables and uncontrollable type of issues that I feel like as we're going through this process now, I feel it is working, and I think our structural engineer agrees. It's definitely been better than what we've done in the past. So I'm curious to see when we get to the finish line how the numbers shake out and how other people feel about maybe making this a new sort of initiative for Davis. So that's pretty much it. Again, I know we are out of time, so sorry about that. But if there's any quick questions, we will gladly answer them now or offline.
We'll do some questions that David proposed. Thank you, guys.
Oh, no problem.
Okay. Sorry about that, guys. So we've got a really interesting presentation next. Apologize for any of the delay and the fact that it was on the screen, just not for everybody else to see. David First with Smith Group has been working with AR and VR for a good 3 years now, probably. We're doing, yeah. So, and has a really incredible presentation on some ways to actually use, augmented reality. So, I'd like to welcome you. And
all right, thanks, Galen. Is mic working okay? Everyone hear me in the back all right? All right, well, as Galen said, I'm going to talk a little bit about how we've been using augmented reality at Smith Group and what I think are some practical ways. A little bit about myself. I split my time at Smith Group. My coworkers often see me in goggles, something like this. I think they've gotten used to seeing me around, wandering the office, whether in a VR headset or HoloLens or something like that. But I actually split my time. I spend about half my time working as an architect on projects, all the way from early design through, construction documents and CA, as we'll see today. And then I spend part of my time working with our national technology and practice group, and I lead our visualization portion of that group. So we do all things from AR and VR tools, but we also look at different rendering tools, really any way that we're presenting our work, either internally or externally, things like 3D printing models, all kinds of things that we're looking at. So whenever I start a presentation like this, I always like to quickly just set the terms that we're working with. I think everybody in here at this point should be pretty familiar with VR versus AR, but just to recap, right, VR is where we're transporting to a new environment. We're sort of fully immersed and we're taken away. AR, we're adding additional information on top of the real world around us, right? So Pokemon Go is the easy one for everyone to see. You're looking at the real world through your phone's camera, and additional information, Pokemon is hopping out and being added on top of that piece there. So it gets a little more complicated. People throw out the term mixed reality, and I'd like to just throw this in here. These are a couple diagrams that Microsoft put together, so take it with a grain of salt because they sort of are the biggest hardware creator as well. But mixed reality is really describing a spectrum with augmented reality on one side and virtual reality on the other. So augmented is closest to the real world, and virtual reality is sort of closest to a fully digital world. And then if we look at that bottom graph, you start to see an interesting idea, which is where we are today with the tools that we have. So interesting to see that mobile phones, they point out, are really on a very limited part of the spectrum. So either you're sort of fully immersed in that virtual world with that phone in front of your face, or you're looking entirely through the camera, maybe adding some additional information, but you're sort of on each end of the spectrum. And I think that's going to improve as technology gets better and better. And we're going to talk a little bit about the Microsoft HoloLens today, which starts to bridge that gap between the two a little bit in a way that you can sort of interact with the environment around you. So on the VR side of things, at Smith Group, we've sort of been all in on VR since we got our hands on the first Oculus development kit about 2016. We've now got an HTC Vive permanent install in all of our offices. This pictured here is actually our Chicago office, but if you come visit us in DC, we'll have a similar setup in our lobby that we like to get good use out of. We've also got travel kits, so we've got a couple big Pelican cases that we send around. They're getting smaller and smaller, but we'll take it to client sites and we'll present it. It's a really nice way for clients to start to understand the space three-dimensionally in a way that's sometimes difficult, with plans and sections. But again, this is VR, sort of a technology that's been around now, and we've gotten used to it. Our clients have gotten used to it. One more thing that's always nice to show it. This is sort of the oldest school of VR, which is using 360 panoramas and something like a Google Cardboard or similar, where you're sort of immersed, but you're in one spot. And I wanted to show this because in my mind, this is almost like our first foray into augmented reality, because it's sort of fake augmented reality, I like to call it. So we say, stand here, look at this phone. This is the view that you'll have. And as you sort of take on and off that headset, you sort of get the idea that you're immersed in the environment and you're feeling the surroundings and what it's going to look like in the future. So as we get a little bit more real off of fake AR into sort of real AR, there's a couple different ways that we can do that. So one is through head-mounted displays, and pictured here again is the Microsoft HoloLens. That actually now is getting pretty old. It was released in 2016, which is really an eternity in this field. And everyone, I think, is excited to see. I think they said February 24th, the HoloLens 2 is supposed to come out. So it's coming soon. But there are others out there, Magic Leap, Daiquiri, and others as well make head-mounted displays for augmented reality. And they all operate under a similar principle, which is that there's sort of a translucent lens in front of your face, and you can add additional information within that lens, but you can still see reality behind it. And the other way that I think is getting ready to explode, as I mentioned briefly, is through mobile devices. So I'm talking a cell phone or a tablet, and I feel like with every release, the technology gets better and better, and the capabilities are stronger and stronger with more interaction with the real world. So both Apple and Google make sort of an infrastructure for developers. Google's is called AR Core and Apple's is AR Kit. But you're starting to see more and more, sometimes really simple stuff like an IKEA app where you can place a chair in a corner of a room and actually walk around it and start to sense motion. So at Smith Group, the first things that we saw when we started to talk about AR were sort of images like this. This is from a Trimble ad, I believe, where you've got three people in a HoloLens. They're all sort of playing around this tabletop model as a way of presenting, which I think sounds great in theory, but we didn't really get a lot of excitement about this when we presented it to our design teams for discussion. It felt a little bit more like a novelty than it did really very useful. We've got three people around a table that are all willing to put on. You have three HoloLenses for them all to use. They all are trained and know how to use it. It's a little bit out there as far as how you're, I think, realistically going to use the tools. So we started to look for what I think are a little bit more practical uses. So one of our first tests was going out to a construction site that you can see is partially framed, and just trying to use it for visualization a little bit. So I'll play a video here. This is Nobliss. It's an interior fit out at 500 L'Enfant Plaza. One of the great things about this building is it's got fantastic views out to the Jefferson Memorial. You look out on the new development at the wharf. So we're going to see our project designer, Rob, walking through the site with the HoloLens, and then we'll cut to sort of what he's seeing from that HoloLens. So it's a really nice way of understanding both sort of what that future design will look like, but maintaining sort of that existing site that is there. So we get these great views. We understand this is completely real, sort of what's going to be there overlaid on site. And we did learn a lot of lessons from this, starting to do some of these interior projects. Some things were just, what do we need to include in the model? What do we really want to see, right? So for instance, in this one, we had the floor model that was important to design. We didn't have the ceiling. We wanted to see what was above. We didn't have any exterior walls, right? If you put exterior walls in there and you're trying to get a really precise alignment, but you've got one mullion that's 6 inches out of whack, even though when you're immersed in this environment, it doesn't really impact you. Seeing those slight differences that aren't vital to the experience really hurt it and make it tough to see. Has anyone, how many in here have actually tried a HoloLens? Show of hands. Handful, good group. I think for me personally, I feel like most people I talk to that tried a HoloLens for the first time maybe didn't quite get exactly what they were expecting. There's definitely some issues that come with using it that aren't like sort of as beautiful as the advertisements show you. So one thing is that field of view that when you're walking around in it, so you've got a lens set up, but actually there's really only a very small portion that you can see the hologram overlaid on. So you've got great peripheral vision, like as a human, that's what we have. But when you're in that HoloLens, really it's a very small area that's covered. And that's another one of the reasons why, when we are talking about those tabletop models at that early design level, like really VR is stealing the show right now still. It's fully immersive. You can really get a feeling for the space. And there's some limitations in the AR world. We also have some issues with daylight. So if it's a really bright space, it's actually really tough to see out of the HoloLens. You can sort of mitigate that. You can try to tint your glasses. There's all kinds of homemade things out there to sort of get a tinting layer on there to help see a little bit better. The calibration can be a little bit of an issue. So while the HoloLens promises that I can sort of walk a site and it will stay nicely calibrated to it, we do find that as we're walking around, we get some issues in calibration of that model. And so one of the ways that actually we found was really helpful to solve this problem, seems kind of simple, is we would always bring to site a laptop or an external screen to mirror what you're seeing on the HoloLens. So just like you saw that video that I captured, basically that's what you're seeing on the screen. So just a small thing that, and again, this is something we've experienced a lot with VR, is that not everyone wants to put on the headset, first of all. Second of all, we have all those issues in clarity from seeing the headset. All those go away actually when you're mirroring the view. So while it takes away some of the purity of the AR experience, I think for where we are today in the technology, it's really helpful for solving a good chunk of those problems. And it also lets a group of people sort of see what's going on. So it's not a singular experience. All of a sudden, you have a whole group that can sort of understand what's happening. And then carefully filtering the model geometry for clarity, as I mentioned. So, making sure those external walls aren't there. When those are there, and we have exterior walls, all of a sudden we can't see those great views that we really set up the whole model to do. So I want to talk a little bit about another project where we really, I think, took another step forward in how we're using augmented reality, and that's at DC Water headquarters, which is down in Yards Park. This was a design-build partnership with Skanska, who worked on this project, and I'll do just a little bit of quickly background on the building, so bear with me here for a little bit as I get through this. But just to understand a little bit of the basics, I think it's really important to understand that in plan, this ended up being a fully curvilinear building, and you understand why that's important in the beginning. But the form diagrams sort of show a simple bar, an ideal office space that gets pushed around actually an existing pump station on site. So there's a pump station on site down at DC Water. It's actually pushing 2/3 of city's overflow water through it on any particular day. So we bend around that. We sort of bend for great views up and down the river. And then we also have to maintain view sheds. So sort of that's where we end up where we are. And we had some very sophisticated modeling that went into sort of building out that facade. And what's important from this diagram is understanding how sort of precisely calibrated our entire facade is. So it was really vital that the areas that we have as particular glass types or metal panels are where we thought they were going to be. So this is showing solar heat gain on sort of a bare form, and then how we've mitigated that with the addition of a secondary skin, as well as placement of sort of punched versus solid openings. And again, this is from our construction document set, sort of showing all of those unique panels across the building facade. We've got several types of glass and 6 different types of metal panels that fit in there on the north side of the building as we move away from the views on there. So we ran into a little bit of a problem as this building started to get finished, and that was it's looking great, but how do we really verify that it's being built as we thought it was going to be built? How am I going to go do CA on site and make sure the metal panel pattern is correct, right? So, do you go out with a flat elevation with this fully curvilinear building and start giving check marks on each panel to make sure it's right? I got tired of even putting check marks into my PowerPoint presentation. I can't imagine being on site trying to figure that out. So we thought there's got to be a better way, right? So we've got this great Revit model that was built as part of this project. We've got fantastic data built into it, X, Y, and Z coordinates. That's sort of how we communicated with Skanska, things like edge of slab and panel coordinates. We've got, most importantly, the panel type. What is it, glass? What kind of glass? What type of metal panel? All that fun stuff. So we thought, how can we sort of overlay these two on top of each other to make this work? And I had to throw in one slide here because I saw that the Davis guys were presenting in front of me, which is one option is bring the site to the model. So I think that's what you guys are doing with your scans, right? So this is actually a presentation I saw at AU this year by Mortensen Construction and ATG, and they had. I'll get the question later. They had this awesome presentation where they showed getting a point, taking daily or weekly flights with a drone, creating a point cloud, and then bringing back to the Revit model to measure from that. So that was sort of one option that we could have done, right? If we were sophisticated enough to have that point cloud information, we could have brought it back to the Revit model, compared what was in that to what we have there. But we sort of chose the inverse, right? As you can tell from the presentation. So we said, let's take the model to the site. So here's an image of our Revit model, and this is where I think some simple things become really important. So one thing that I did, it became evident to me quickly as I started testing out the technology, is the HoloLens was not going to be clear enough for me to tell slightly different shades of green in the HoloLens apart from slightly different shades of green on site. So we sort of started to think about ways that I might be able to tackle that problem. And in the end, what I did was I built a really simple Dynamo script that placed these generic models all over the building. And they're just telling me what kind of panel it is. So I've got 1, 2, 3. I've got 3P and 2Ps floating around for perf panels. And those are just placed smack in the middle of the panel. And sort of that was what I was going to use to get information back to me on site. And in the end, actually, that's the only thing that I'm doing on site. So I'm not actually, in the end, looking at my documentation Revit model at all. I've added this additional layer. That was fairly easy for us to make because we had all the data already in the model. But it was just a matter of sort of understanding how the technology works and what our end goal was from this. So for this example, we used a nice piece of software called HoloLive, which has a really simple interface. You basically pick 2 points in the Revit model, and then you go out on site and you find those 2 points, and you use those to place your digital model on site. So I've got a video that will show that whole process. What it's going to show is sort of beginning, it'll show the Revit model, show those isolated tags as we're moving around it, and then sort of how I'm placing it on site. So let me get that going. So here we have the headquarters building, and you can see that we are just about done at this point, and DC Water has moved in. So here's that live Revit model as we move around, and you can see those tags, and actually each of those curtain wall panels has all that important data built into it. Here's those isolated, and for this example, I'm just looking at the metal panels. I zoom into an existing building on site. That's that pump station that we talked about that has to stay working throughout construction, and you can see the triangulation and the scanning as I place those 2 points on site, and now my sort of tags are calibrated to site. And you can sort of see this whole building. I see all these numbers. Actually, I can see through the building because I'm seeing the numbers beyond. But as I move around, I'm close enough that I can sort of get an understanding of exactly which panel's in the right place. So I see a perf panel's missing up at the top, and sort of get a quick understanding of that. So that's sort of the bones of it all. I think it's really a question of sort of how can we make this a little bit simpler. We did have, we had a lot of issues that we tackled along the way. We dealt with those daylight issues. Lucky for us, the panels are on the north side of the building, so we were mostly in shade and could see that. But we did have issues when we were trying to get into the sun and to calibrate things. We had issues, in theory, I should be able to walk around the whole site with the HoloLens and my panel tags all stay in place and I can see if everything's right. In reality, I set up some strategic points around the building, would recalibrate as I moved and checked. Actually, being on site and looking through the lens was really nice. But what became really powerful as a documentation tool was actually that video that I took, right? Because then I can go back afterwards and make sure I didn't miss any of those 800 panels that were wrong, that might have been wrong, something in there. So that was really helpful. So to just finish things out, some conclusions is understand your goals. Okay, so understand what you're trying to do at the end. Set up your model for success by just sort of aggressively filtering down to what you need. I think this technology has really limitless potential. I mean, this is one small thing that we did, but I'm sure there are so many others out there. I mean, talk about clash detection or all kinds of other things that could be going on site, whether from an early visualization phase or much more into construction. And then have a presentation strategy. So what's, are you mirroring to a screen? How are people experiencing this? Are you having multiple HoloLenses on site? What's the goal here, and what are we going to do? So thank you. That does it for me, and happy to answer any questions.
Since Gravit's not here, I'm not going to kick you guys out at 8 o'clock. They may come and get us, but who has questions? I know there's something going around in here. No? Questions? I guess that's why we stop at 8 o'clock then. Brain shuts down. Well, thank you very much, David. Thank you, everybody. Everyone else will be around. You could grab them if you didn't want to talk over the group. But thank you all for coming out tonight. Remember, do the surveys. We'll use them to come up with the next agendas for the rest of the year. So thank you all.